Hi students, welcome back. Coming to the next topic, that is the intermediate code. Let's see what is this intermediate code. You already know at what stage this intermediate code will be there. In the compiler, first you are having the lexical analyzer, next is the syntax analyzer and the semantic analyzer, next is the intermediate code generation. After that, the intermediate code and then code generator, optimizer, everything. So this all comes under the phase 1. This is the front end and this is all the back end. So this concept you already know. So now we will discuss what is this intermediate code. So far we have seen the lexical analyzer, syntax analyzer, and the semantics is just representation of the means. It's a semantic rules we discussed in the syntax directed translation. Now let's see intermediate code. It is used to translate the source code into a machine code. The main concept of intermediate, it is the name itself is saying it is an intermediate, acts in between, okay, from source to destination. If you want to reach from source to destination, there is a mediator is there, that is an intermediate. So it is from between the source and the destination, that is a source code into machine code, or you can take it as an assembly code, means the compiler will give the result as an assembly code. Okay, so it is used to translate the source code into the machine code, which is an assembly language. It lies between the high level language and machine language. So let's take, this is a parser. Okay, you know that the parser is that represented as a syntax analyzer. Okay, so parser is first static checker will be there with the help of the semantic analyzer. Next is the intermediate code generator. So this intermediate code generator is going to give the already converted information to the code generator with the help of the intermediate code. So okay, so the intermediate code generator is generating intermediate code to the code generator. So this intermediate code consisting of what the compiler wants, means already it is in the form of readable format of the code generator. Okay, so it is almost readable by the destination. Okay, that is a target language. So if the compiler directly translate the source code into machine code, let's take if the compiler is going to directly transfer from source to the destination, so source code to machine code without intermediate code, then a full native compiler is required for each new machine. So whenever there is no requirement for the, if you are not introduced intermediate code, let's take, suppose there is no intermediate code in the compiler, so then what it is doing, so for whatever the new machines, whatever the machines you are taking, for each and every machine there should be a full native compiler is required for each and every machine. So okay, so if the compiler is doesn't having intermediate code generator, then for each and every machine a full native compiler is required. Otherwise there is no multiple compilers are not required for each and every machine if there is an intermediate code. Intermediate code generator receives input from its predecessor phase and semantic analyzer phase. So we know that. So this intermediate code is going to receive the information from the predecessor phases. It takes input in the form of annotated syntax tree. So all the intermediate code will take the input as a syntax tree, because whatever the lexical analyzers is taking the tokens are converted represented in the form of parse tree. Okay, so the parse tree is going to be converted in the semantic with the help of the semantic rules with like annotated syntax tree. So that I'll explain now what is this annotated syntax tree. Okay, so then the intermediate code will take the input as annotated syntax tree. Using intermediate code, the second phase of the compiler is changed according to the target machine. So that I said now. So intermediate code can be represented in two ways. One is a high level intermediate code and another is a low level intermediate code. So you can represent the intermediate code as high level and the low level. High level is nothing but it can represent it as a source code. So whatever the data that you are taking, that data is taken by the intermediate code is at the source code. That is the high level. So whenever it is coming down, it reaches to the low level, because it has to reach the assembly code. It has to convert the data into assembly code. So that is the low level. So from high level to low level. So the intermediate code can be represented in high level and the low level. Why it is representing in both? The intermediate code is representing in both high level and the low level. Why? Because it is acting as an intermediate between from the source to the target. Okay, so don't be confused. Let me tell. So this is the source code and this is the target code. From source code to target code, there is a help of intermediate code. Intermediate code. So this intermediate code is at the top, it is in high level language, and at the bottom it is in low level language. Okay, so before that, all the data that is taking as an input, it is in high level, which is a source code, and below that intermediate code, it is in low level, because it is reaching to the target machine. So that is converting into the low level. So this intermediate code is just taking the source code as high level and converting into the low level, which is helpful to the target machine. I hope you understand what exactly this intermediate code was. Okay, so now let's see the different forms of intermediate code. There are different forms will be there. One is the abstract syntax tree, polish notation, and tree address code. So in the next video, I'll explain all these different forms of intermediate codes with an example. Thank you.